or no? Who is that? Loss. So Mritula, where are you? Okay, Akhil.
Ma'am, can you hear me?
Yes, yes. Mritula, so I'm going to give you one work. So you just unmute your mic, and whenever I ask some question, you have to respond. Means I want somebody to tell me that whether I'm online or not. Okay?
Yes,
Okay.
ma'am.
So we'll
Yes, ma'am.
last class you people expressed me that the topic is somewhat heavy, difficult to understand. So I thought that okay, let me put it in a simple way so that you can understand at least the overall uh, concept as well as the context of each and everything what I discussed in the last class. So the today main objective of today's session will be to make you to understand on significance. Can you see the pointer?
Yes, ma'am.
Which color it is? Red or green?
Red, ma'am.
Red, okay. So the main objective of today's session is to make you people to understand the significance, that is importance of energy in shaping the weather system. So we have been discussing on climate change. Under that, I started with what are all the environmental issues developed in the past because of various developmental activities, be it industrialization or agricultural activity or infrastructural development or in the form of energy resources. So the world is facing a lot of problem as and when the development is picking up the momentum, right? And then at a global level, various initiatives had been taken in the past to just curtail the changes caused by or brought out by the developmental activities. So that triggered up the awareness across the countries as well as at international level that they should restrict their activity. So some various initiatives were taken towards the sustainable development, and so we have seen the various sustainable development goals and the target year also. Then after that, we discussed about the basics of weather, and under that, I told you what is the role of sun. So how the electromagnetic spectrum, while traveling through the atmosphere, various layers of atmosphere, what all the fate it undergoes, and while it enters the lowermost layer, that is atmosphere, how it is being absorbed and how it is being reflected, and what amount of energy actually touches the earth's surface, and after that what is happening to that absorbed energy after the sunset. So that also we have seen. And after that, I told you, and the energy budget, it is nothing but the energy gain and energy loss of the earth atmosphere, right? And whenever the gain is more than the loss, we say that budget is positive, and when the loss is more than the gain, we call the budget as negative. And so accordingly the earth will undergo the warming phase or the cooling phase. Okay. Then we discussed about the role of the energy budget in shaping the weather. So in the weather, two important air movement of the air and water mass um, defines the weather of that particular region. So here your air, the most important factor next to the energy is the air, and so the movement of air depending upon the pressure gradient around the globe plays a significant role in exchanging the energy from the point where more energy is available to the point where it is less, right? And next to the movement of air mass, your water movement, that is the oceanic current, the movement of oceanic current also plays a secondary important role in shaping the weather of that particular region. How? By just transferring the heat from tropical region to subtropical, and from subtropical to polar, and reverse from polar to subtropic, and subtropic to tropic. So by this way, the energy is distributed throughout the water bodies, and so these both, that is the movement of atmospheric circulation as well as the oceanic circulation, indirectly plays a significant role in deciding the weather. So you should remember one point, that these two movement of the air and water is largely driven by the energy, and so depending upon the budget of the energy gained by the earth, the movement may be rapid or it may be slow. So that basic thing you should understand. Okay, are you all clear?
Yes, ma'am.
Okay. So, and last class I told you how, that is we specifically we discussed on the atmospheric circulation. So under that I told you about Hadley cell and Ferrel cell, polar cell, and the polar front, right? And so last class I just gave you the insight how these cells are distributed latitude wise across the globe. So I gave you the degree also. We discussed the Haas latitude, right? And we also discussed the polar front and the equatorial region, and how the pressure belts are distributed, where the high pressure belt is present, where the low pressure belt is present. And according to the high and low pressure, distribution of low pressure region, how the movement of air is taking place. So that and all we have seen in the last class itself. So to give you more insight on each cell, we are going to I have planned some simplified slides, so that you will get very good understanding on the topic which I want to tell you. Okay, and so let's start with the Hadley cell. So you have to answer my question so that I will get to know whether you have understood or not, and I may be able to understand whether I'm on right track or not. So first follow the cursor point. So this is the equatorial region, and on the either side of the equatorial region, you could see the blue color cycle, right? Can you see?
Yes,
Yes,
ma'am.
ma'am.
Right. So in the northern hemisphere, this is the North Pole. So this is the northern hemisphere. In the northern hemisphere, the air mass, that is blue color arrowhead, rises, and then it travels to certain extent, again it sinks, right? And after that again it spreads and moving towards the North Pole. Okay, and similarly, so this cycle is Hadley, and this cycle also Hadley cycle. Okay, so now we have to understand how this cycle is getting completed. That is very very important. So where is the beginning point? The beginning point of the cycle is the equatorial region, on either side of the equatorial region. And so since this portion is getting more amount of sunlight, that to perpendicular sunlight, it is heated up quickly, and this heated air mass expands. When it expands, the density become less, and because of the lesser density it moves up and up to the certain height, and once it reaches certain height, because of adiabatic cooling process, it could not move further up, and therefore it start traveling horizontally, okay, towards the north pole. And because of the north pole, and once it travels, it come across the 30-degree latitude, and beyond that it cannot travel. Why? Because that is the point where it would have reached the maximum cooling temperature, so it will become cool, and the cool air will sink. So two things you should understand: the point where the air rises, that region will be low pressure region, because there is no air mass over there, because all the heated air are leaving the land surface. Therefore at the land level the pressure will be low, right? And then the second point is the 30-degree north and south. So this is the point where the rising air cools and sinks, right? So since the sinking air will not have, because while rising itself, whatever the water vapor carried by this air will become condensed, and it will give the rainfall in this region, where 10 to 20-degree north and south latitude will get sufficient amount of rainfall because of the low pressure region, right? So the sinking region, that is 30-degree, the air will not have any condensed water vapor, because all the water it lasts in the form of precipitation over 20-degree, up to 20-degree north and south of the latitude. So the air will be very, very dry, and that is why this region is called calm region, and therefore the name horse latitude is given. And I told you the story also why it was named so, right? So this is and so here you have to complete the cycle. So here at 30-degree latitude north and south latitude, only half of the cycle is completed. So the Hadley cycle, to complete it, should come back to the equatorial region. Got my point? So we are here, okay. So the sinking air will be cool, and the sinking air, after touches the land surface, here the pressure will be low, that is tropical region. Already the air left the surface, therefore this region is low pressure region, and this region is high pressure region. So the sinking air moves from high pressure to low pressure region towards the equator. And here also the sinking air will move from 30-degree, that is high pressure, to 0-degree, that is low pressure. Okay, so thereby the Hadley cell is getting completed. Okay, so Akhil only asked this doubt last class. Akhil, are you clear, Akhil?
Yes, ma'am. Yes, ma'am.
All of you? Mritula,
Yes, ma'am.
Veena, and rest of the
Yes,
class?
ma'am.
Rest of the class?
Yes, ma'am. Yes, ma'am.
Okay, fine. So this is about the Hartley cell. So what point you should remember is where the high pressure will be. So high pressure will be in the subtropical region, that is above 30-degree of north and south latitude, okay. And where the low pressure would be, the low pressure would be very close to the equatorial region, 0 to 15 or 20-degree north and south of the latitude. And so another important phenomena you should remember: the air mass where it rises, that is the low pressure region, and these are the places that get sufficient amount of rainfall because of the precipitation given by the rising air mass. After reaching certain height, it condenses and brings rain to the land mass. Okay, so this is the divergence. This is the region of diverging region. This is the region of divergence. Divergence means the two air mass move away from each other. Instead of meeting together, they move. So at the atmospheric level, it moves away. divergent region. Whereas the point where the cycle closes, that is the converging. So the air mass will converge towards the equator from the north and towards the equator from the south. So near the landmass, the air will be converging, and above the landmass, the air will be diverging. Okay, so this is what the Hadley cell is. So with this backdrop, you can read this slide. So I told you, near the equator, the air separates and it starts to move both north and south towards the pole. And when it reaches about 30-degree north and south of the equator, the air cools up and sinks down, forming the subtropical high pressure zone. So I told you about intertropical convergence zone, ITCZ, right? Do you remember? So ITCZ zone itself is moving slightly because of the temperature fluctuation or the energy budget. So it may move towards the northern hemisphere a little bit, uh, in some part of the season, and it may move towards the southern hemisphere during some part of the season, depending upon the tilting axis of the earth, right? So at time being, you have to remember the high pressure zone. Okay, where the high pressure zone would be, the high pressure zone would be formed at exactly at 30-degree north and south of the equator, and the name for this zone is horse latitude. And as the air sinks, it becomes warmer and drier, and this creates an area of little cloud and low rainfall. So I may ask you why the horse latitude does not get sufficient amount of rainfall, why the air is very very quiet. So the answer would be the air is warm and it is dry without any humidity, and therefore there is no air movement, there is no pressure gradient, and therefore there is no cloud formation, therefore no rainfall at all in places that are located near to this latitude. And mostly, if you carefully see the map, you can easily find out that most of the deserts are located only in these regions. So the reason would be the less rainfall. Are you clear?
Yes, ma'am.
So
Yes, ma'am.
Yes, ma'am.
next cell is the Ferrel cell. So Ferrel cell is here. So now we have to focus on 30-degree north and south of the equator. So at 30-degree, the air sinks, right? The sinking air will, that is now just imagine above the ground, that is touching the ground, you will be having the cold air. So this cold air is heavy in nature because the temperature is low, and therefore it tends to move towards the north. And similarly, here the sinking air mass creates the high pressure and it is denser in nature, and therefore it moves away towards the south pole, right? And another important thing is this air mass, because of the depending upon the region where it is present, it may tend to deflect either towards right hand side or towards the left hand side. So if it is in the northern hemisphere, suppose say for next slide I will show you how this will be taking place. Time being, no worry. So this suppose you just carefully follow. This red dot is the air. Okay. So it should travel straightly towards the North Pole, but it won't do. It will slightly deflects towards the north. Why? Because in the northern hemisphere, because the earth itself is rotating, so in the northern hemisphere, because of the Coriolis force, the straight, instead of straight movement, it will deflect towards the right hand side, whereas in the southern side it will reflect towards the left hand side. So that is why in the Hadley cell, the easterly winds, it is called easterly winds instead of northern wind, instead of what to say, yeah, southern wind. So it is moved from south to north. So the air is named from the direction where it originates. Okay, so in that case, it should be named as, it should be called as southern wind, but it is not so. But what we are referring these winds are called easterly wind. Why? Because it is tilted towards the east, and similarly here also towards the east. Okay, so these are called trade wind in the Hadley cell, whereas in the cell they are called westerly because the point of origin is west direction because of the Coriolis force. Okay, so the air masses move towards the north and south here, and after reaching the 60-degree north of the equator latitude, it rises up. Why it rises up? Because from the poleward side, this polar cell is there. From the poleward side, the cool air moves. Okay, so this cool air is heavy in nature comparatively to the air which is present in the Ferrel cell. So therefore, this it tends to rise up, okay, and forming the Ferrel cell. So with this background, we'll go to the Ferrel cell. So the Ferrel cell occurs at higher latitude between 30-degree north and 60-degree north, and 30-degree and 60-degree south. Okay, so this is the 30-degree, and where it ends 60-degree. So 30 to 60-degree north, 30 to 60-degree south. This is the place where this cell is taking place, right? So this point is very, very important. So the warmer air from the tropic is lighter than the dense cold polar air, and so it rises as the two air masses meet. This uplift of air causes low pressure at the surface and unstable weather conditions that are associated with mid-latitude depressions. So much of wet and windy weather in the UK is determined by this. So let me go to the picture. So this is the 30-degree, and this when compared to the poleward air, the subtropical air are a little bit warmer. So comparatively, so if you compare the tropical air with that of subtropical air, the tropical air is very, very hot. Similarly, when the subtropical air is compared with polar air, the polar air are cold and this one is warmer. So the warm air will definitely rise up. The warm air will definitely rise up. After reaching certain height, it condenses and brings rain to that place, and then dry air travels, and after reaching certain height, it cools down, and this cool air sinking and completing the cycle. So this cycle stretches from 30 to 60-degree north of the equator in the northern hemisphere, and 30 to 60 degrees south of the equator in the southern hemisphere, and this is the region where the high pressure is formed. So high pressure is formed. Okay, so here low pressure, high pressure, again low pressure. So this is the region where low pressure is formed. So low pressure region இருந்துச்சுன்னா ஆட்டோமேட்டிக்கா என்ன ஆகும்? So low pressure, north pole will be having high pressure. So from the high pressure zone, the air will move towards the low pressure. So this place will get more rainfall. Are you clear? Clear?
Yes, ma'am.
Okay. So next is the polar cell. So at the pole, air is cooled and sinks towards the ground, forming the high pressure. And this region is known as polar high. It then flows towards the lower latitude. So this is the maximum degree, that is pole side 90-degree. Okay. So from the 90-degree, the air mass will move towards the lower latitude, that is towards 60-degree, right? Approximately 60 to 65 or 75-degree. Okay, and adhe madri in the southern hemisphere also the air will move from poleward side to subpolar region. Okay, and See, the cold polar air mixes with warm tropical air and rises upwards and creating a zone of low pressure called subpolar low. Okay, so this is the zone of depression, and this is the zone of depression. Okay, so this air mass is cold air and this air mass is warm air, right? So that, do you remember last class I told you cold front? So here the mass, the air mass, the volume of the air mass will be very high and the temperature will be very very low, and this region, that is subpolar region, the temperature will be warmer, and so this warm air mass will meet with the cold air mass. So that frontal zone, the region where it faces, the mixing is taking place. That is the air, warm air from the subtropic and cold air from the polar, where it meets. That is called cold front, because the cold air is more, therefore it is called cold front. And this place is very very important because it is highly unstable in nature, because huge temperature differences are there between the subpolar and the poleward polar air mass. And so this region is called uh, polar high, and the region where it sinks is called subpolar low. Okay, and because of this pressure differences, you will get the cyclonic phenomena very frequently here, right? So, as I told you, the boundary between the warm and cold air is called polar front. It accounts for a great deal of unstable weather experienced in this latitude. So, why the weather is very, very stable? Because it frequently, the huge amount of cold air from the poleward side moves down south and meets with the warm subpolar air, and as a result the tremendous pressure difference and the rainfall and the wind movement will be very very violent, and this brings cyclonic effect in this latitude. Okay, so by the time you might have understood how the air mass plays a significant role in bringing the or in deciding the weather of region. So, depending upon the location of the continent may get rainfall or it may not get rainfall. Say, for example, if we take Africa, so the Africa, the equatorial line crosses Ecuador region. Okay, so this is the region where you will get plenty of rainfall, and most of the tropical rainforests are situated along this zone, right? And similarly 30-degree, whether it is, so you will remember that our Thar desert is here. Okay, the great Indian desert is located here. So at 30-degree, all the deserts are situated, be it in Indian continent or Europe or Africa. Okay, so African region, Sahara, Kalahari Desert, okay, Latin America. So wherever it may be, but depending upon the location of that particular continent, where this latitude is located exactly, it may come across come across heavy rainfall or no rainfall at all. Accordingly, the vegetation as well as the ecosystem will also form on such regions. Okay, so therefore the weather plays, the movement of the atmospheric air plays a tremendous role. But what makes this air mass to flow? The definitely there is no doubt in that. Only the energy which is gained by the earth decides the movement of the air mass. So with this background, let's move on to the second giant movement of the uh, air, that is liquid in the form of ocean. So first liquid is atmosphere, the second one is the ocean currents. So one before we get into the topic, we must understand that how the ocean currents are formed, and similar to the atmospheric circulation, the ocean currents are formed by the temperature difference as well as the movement of the wind. So without the movement of the wind, the oceanic currents will not move that much. Okay, and so therefore the ocean currents are moved by the surface winds associated with atmospheric circulation. So this atmospheric circulation gets energy from the sun, and the ocean currents gets energy from the atmospheric circulation. So in that way, one leads to other, and if whenever there is fluctuation in one parameter, then it will reflected on the other parameter subsequently. But it may take time. Immediately, it will not show that effect, but it will take time to exhibit the impact abruptly. Okay, and the direction of the water movement is also deflected by the Coriolis force. Like as we seen yeah, while we discussing about the atmospheric circulation, here in oceanic circulation, the role played by the atmospheric circulation as well as the movement of the earth, that is the rotation of the earth, these two are very very important factor. So whatever I said while discussing the atmospheric circulation is also applicable to the oceanic currents. So that means what? What is Coriolis force? Like when air moves towards the North Pole in the perpendicular direction, that is 90-degree angle, and if the air mass crosses the northern hemisphere, because of the influence of Earth's rotation, it will slightly get deflected towards the right hand side. Similarly, in the southern hemisphere, the air mass will deflect towards the left side in the southern hemisphere. So similar phenomena is also taking place in the ocean due to Coriolis force. So this force is called Coriolis force. So in this picture, you will get to understand what I'm trying to convey you people. So here I told you that this is the red color line indicates the warm current, that is surface current, and this lavender color represents the cold currents. Okay, and see the warm air, it will be present at the surface level of the ocean, and these, since you always remember that the warm water will be lesser in density, right? So because of the less density, it tends to carry forward by the atmospheric circulation. So the surface air current, it just pushes the warm current, that is warm water, across the oceanic region, and therefore it travels very fastly. Okay, and as it travels fastly, it has to crosses the equatorial region, 30-degree, 40-degree, 50-degree, 60-degree, like that. So it should travel. While traveling, it may come across when it reaches the higher latitude, then because of the temperature difference, that region itself will be having cold air, and the water itself will be cool in nature, and that so it loses its energy. So while traveling towards the northern hemisphere, the water current loses its energy slowly. Okay, so as it loses completely, then it sinks, because you know very well that when it loses the temperature, the energy will become low, and so it become denser, and the dense water column will sink, so forming the cold current. Clear?
Yes, ma'am.
Okay. Okay, with this backdrop, so pressure and all, see here the water, the wherever the surface water current is very hot, uh, the water will move fast, because the density of that water column will be very very low, so it tends to move very fastly by the airflow, right? and as a result, this region will get a low pressure, and that is why, especially if we take India, the southernmost, that is peninsular India, is facing tremendous issue related to cyclone, the storms. This is the place where so much of the natural hazards are taking place very frequently. Why? Because of the rapid movement of the surface ocean current. Okay, so this leaves that ocean and creates the low pressure, and therefore the cold current from the extreme north will move fastly to fill up the low pressure region. So the meeting place where, that is the low pressure region, or the place where the cyclones are formed, and high pressure regions are those regions where the cyclones are not at all formed. So this but basic thing you should remember. So based on that particular, that is previous slide, two phenomena you should understand. One is anticyclone, another one is depression. So I told you this is the region where the cyclone will never form. So these regions, that is high pressure regions, are called anticyclone, and these regions are vulnerable for cyclone. Why? Because the pressure is very very less. So such regions are called depression. So depressions will invite the cyclone, and anticyclone region will not get any cyclone at all. So to make you people to understand little further, that is more, you just remember that this is the continental region. So you can consider this as the landmass. Okay, so this is the land region, this is the coastal region, and this is the area occupied by the sea, and this is the Greenland and the UK, Britain. Okay, right. So this continent is surrounded all the side by the sea. Okay, so what here you can see the continental wind. So there will be difference, the pressure difference between the continent and the ocean. So you might have heard about this during your school days. So this is the wind which moves from the continent towards the sea is called continental wind, and the wind which moves from the ocean towards the continent is called maritime wind. So the maritime wind will be mild, and it brings the summer will be very cool, and this brings heavy rain. So I told you last class, I gave you example of Kerala. So Kerala, the wind moves from Arabian Ocean, Arabic Kadal, Arabian Sea towards the Kerala. Okay, that brings heavy rain to the Kerala. And there the winter will be very mild and summer will be very cool, right? Whereas if you take Tamil Nadu, so the continent, and this mild, this maritime wind, it has to cross the western. Just imagine that instead of this country, just imagine the western coast, Western Ghats. So it has to rise up and up to cross the mountain. Okay, so all the rain catched by the landmass of Kerala, and only the dry air crosses the Western Ghats, and then it travels to Tamil Nadu, and whatever moisture is available in Tamil Nadu landmass, it just capture. Okay, so that is why Tamil Nadu is not able to get sufficient amount of rainfall. See, just imagine, see how beautifully this weather is molded by the movement of maritime wind and continental wind. So coming to the subject back, so the purpose, the main aim of putting this slide is to make you people to understand how the Coriolis force plays a role in deflecting the wind direction. So I told you that maritime wind move towards the west. Okay, what to say? Yes, this is the north, this is south, and this is east, and this is west. So from the west direction it travels, and because of the force it just slightly deflected. Okay, and as a result it becomes northwest. And similarly it is from the east, so east wind, but because of the Coriolis force it just deflected towards the south, and therefore southeast. Okay, similarly southwest, the tropical winds from southwest direction, south direction, since it is the southern hemisphere it deflected towards the western side, so southwest. Similarly the air from the north pole, and it moves towards the south. Okay, but origin is north, therefore north, and because of the northern hemisphere it deflected towards right, so northeast. So in this way the wind that travels from the ocean or the continent, or depending upon the direction from which it originates, get deflected by the Coriolis force, and according to the direction towards it get deflected, different names it gets, like northwest wind, northeast wind, southeast wind, and southwest wind. Okay, so this you have to understood, right? Clear?
Yes, ma'am. Yes, ma'am.
Okay. So let us move on to the important topic. So we have completed the atmospheric circulation. Now we are going to discuss the oceanic circulation. So here also two important thing like atmospheric circulation, two important phenomena plays an important role, that is convergence and divergence. So convergence means the two different water mass meet together. Okay, that is the point of convergence. And divergence means two different water mass having the two different temperature, instead of meeting it move away from each other. Okay, so this movement carries or it shapes the weather of that region, and it also decides the salinity of that region, and it also decides the wind pattern of that region. So we have to understand very clearly the types of oceanic circulation depending upon the temperature it has, and depending upon the region from where it originates. There are two, that is fast and energetic surface circulation and slow and large density driven circulation. So let me repeat it again. The first one is the fast and energetic surface circulation. So you can very well understand that this fast and energetic surface circulation will be of warmer in nature. So it represents the warm water, and the slow and large density driven circulation, there is no doubting that it is nothing but the cold current. So these are the two major current, warm current and cold current. So warm current can also be referred to as energetic surface circulation, and cold current can also be referred to as density driven slow circulation. Okay, so we have come to the end. Oceanic circulation is very, very sensitive to the global freshwater flux. How? So, to get the answer for this question, let me repeat it again. Oceanic circulation is very, very sensitive to the global freshwater flux. So, see how the energy budget decides the movement of the atmospheric circulation, how the atmospheric circulation, which in turn decides the movement of oceanic circulation, how the oceanic circulation, which in turn decides the freshwater flux. See how one phenomena is correlated or interlinked with another one. Okay, so it is a chain reaction. Therefore, if there is a change in one phenomena, then definitely it will reflect on or it will reflect over the subsequent phenomena, and though it will not reflect immediately, but it will take some time to get reflected over literally. Okay, so now in this slide you will get to know how it is taking place. So in this slide you will understand, see the arrow represents the movement of surface current and the subsurface or deep currents. Okay, and see the red arrow represents the warm current, and just imagine that this is the north pole and this is the south pole. So now I'm discussing the movement of water in the horizontal manner. Okay, it is not vertical manner, the one which is taking place in the atmosphere. Okay, so this is the horizontal movement, what to say, advection. Okay, instead of convection it is advection. Okay, and so this is, just imagine that this is the equatorial region. So the warm, it absorbs energy, and from the equator it will move towards the north, and after reaching certain latitude, like similar to atmosphere, and depending upon the nature of the coastal region, depending upon the continent, whether it come across any continent, or whether there is any gulf, or whether there is any bay. Okay, whether the water depth is more or it is a shallow water. So many factors are there. What is the salinity of the water, what is the pressure of that region, what is the temperature of that region. So depending upon these factors, after reaching that point, it will tend to sink. Why? Because this region is the colder region, Arctic region. White color represents ice. Okay, after reaching this point, it loses the temperature, or something will be there that will not allow the warm current to travel further, and as a result it sinks. Okay, after losing its energy completely, it sinks down, it sinks further, and at one point of time it becomes cold water. And why it sinks? Because of the density. As it loses its energy more and more, it becomes heavier and heavier and heavier. And once it becomes heavier, it cannot move fastly because the energy is very less. And considering the depth of the water column, because of the hydrostatic pressure, it cannot move freely into the ocean, and therefore it moves very slowly. It moves very slowly. Okay, and then after reaching certain point, again it gains energy and it becomes the warm current. Okay, and here you can see the yellow color arrow. These are the point where the convergence will be taking place. Okay, so here you can see very well. I told you, like unlike air, it will not move freely across the oceanic region. Why? Because the movement of the water current is obstructed by the landmass. So how it moves? So these are the places you have the equator. Okay, so the warm currents available in the Pacific region. Okay, so it just moves because either side the continentality is there, so continent is not allowing to move towards the east, or it will not allow to move towards the west. So as a result, and because of the Coriolis force, it deflected towards the eastern direction, and then once it deflects, this deflected current, slowly it sinks. Okay, so slowly it becomes purple in color and then blue in color. So this is the place, at least 30 to 40 degree. So it sinks down and slowly it loses its energy and it becomes the cold current. Okay, and so it moves towards the north and it become completely cold current. Okay, and similarly, here see, you can see some of the places where the yellow color ring is there. Okay, so this yellow color region represents the progressive downwelling. So what is mean by downwelling and upwelling? So the purple region indicates the upwelling region and the yellow regions downwelling region. Upwelling region is the region where The cold current emerges, that is the cold current emerges, that is it cold currents come to the top, come to the surface, and warm current sinks. So the warm current from the tropical region sinks down and allowing the cold current uh, to emerge out. Okay, and as a result, here this region is called downwelling, means it sinks instead of coming up, it sinks down, and this place will not get sufficient. So this plays a significant role in economic activity also, or in terms of fish productivity also, in terms of fish productivity. So these yellow color regions are the regions where the fish catch will not be high. Whereas the upwelling regions are there, these are the places where you will get the good amount of fish. Okay, where so this point is there, and here one point, and similarly here also Labrador current. So here also we will get, here also this region also will get. So next class I will give you the clear cut picture. This is not that much clear. So one thing you need to understand, what I'm trying to hear, trying to convey here is upwelling and downwelling. So the point where the two currents are diverge. Okay, so this diverging point where the cold current will emerges, and the cold current are rich in nutrient, and these nutrients are brought to the surface level, and as a result the phytoplanktons, that is the planktons, or the single cellular, the vegetative material, and they can photosynthesize, and based on these phytoplanktons the small fishes are surviving, and the small fish will eat these phytoplanktons, and therefore at the time of this what to say, the upwelling time, you will get more amount of fish. Okay, and why? Because the fish, in search of getting the phytoplanktons, they travel towards this region and get nourished, and therefore the productivity will be high. And excuse me, and you can link this with that of El Nino and La Nina. I told you that the intertropical convergence zone, sometimes it will deflect towards the north and towards the south, and El Nino related southern oscillation, because this is taking place in the southern region, and therefore this is called ENSO, El Nino related southern oscillation. You might have come across this phenomena earlier by Dr. Mohan Raj, would have told you, but anyhow, it is my duty to repeat it again. And as a result, because of this, some abnormality will be taking place in the ocean of this Australia. That is, I'm talking about this region. This is your Latin America, and this is Australia. So this phenomena is taking place only here. And so during the December, and uh, normally the Peruvian, this is the Peru coast, normally this Peruvian region will be having the cold water, and if warm water occurs in this region, why it occurs, why warm water occurs in this region? Because actually this warm water should be here only, but sometimes whenever the temperature gain is more, instead of forming here, it will form here itself. Okay, it will form here itself, near, very close to the coast of Peru. And as a result, the Peruvian coast will be having these warm current at the surface level. So the fishermen, no, they noticed. So whenever they witnessed the warm water presence at the surface level, they observed at that time the weather was very, very dry. They observed the dry weather, and at that time they get only less amount of fish. So why? Because when the surface water is warm in the Peruvian region, actually it should have been taking place here, but instead it is taking place here. And as a result, these less dense warm water will not allow the cold water to emerge. That is, upwelling will not take place, right? And as a result, the fish will not come here. So it affects the fish productivity. See how the energy budget, how the global warming gases, that is greenhouse gases, adds up the positive energy budget, and as a result, how it alters the atmospheric circulation. As a result of altered atmospheric circulation, how the oceanic currents behave abnormally, and because of the abnormality of the movement of ocean currents or flow of ocean current, how the economy is getting affected. So these phenomena are interlinked with each other. So I would like to end the class here. Okay. So if you have any queries, I would like to address those queries. So you understood, no, the topic very well?
Yes, ma'am.
Okay. All of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Pradeepa,
Yes, ma'am.
Mohanlal,
Yes, ma'am.
Mahesh. Nowadays you are
Ma'am,
becoming so alert. So next madam will call you Nivitata. So understood?
இல்ல மேடம்.
No one.
எஸ் மேம். அந்த இல்ல மேம் இந்த கடைசி ஸ்லைட் மட்டும் கொஞ்சம்
Okay.
காம்ப்ளிகேட்டடா இருக்க மாதிரி இருக்கும்.
Okay, no worry. Next class I will take this belt. The movement of ocean current is called conveyor belt. Okay, so whatever topic I'm handling is very important. Uh, you will get the questions from such areas in the UPSC examinations. So, and not only UPSC, even TNPSC also will ask such type of question. So you pay attention. Suppose if at all if you want to give competitive exams, definitely it is going to help you in understanding the topic very well. Okay. So Akil,
Yes, ma'am.
okay, Mahesh, I'll come to you. Which part you feel very difficult to understand?
Ma'am, I think this conveyor belt part is very difficult to understand, ma'am.
Oceanic circulation.
Yeah.
Okay. Oceanic circulation. See, just imagine that surface level near the equator, the water temperature will be warm, right? So this warm water will travel easily by the wind. Okay. So wind, whenever the surface wind flows, it pushes the warm water which is available at the surface of the ocean. This is clear, no?
Yes, ma'am.
Right. Like how the Hadley cell, Ferrel cell, and polar cells are formed. Similarly, instead of cell, here the currents will be formed. Okay. And this warm current, it travels towards the north. But because of the Coriolis force and continental availability of continents, it get deflected. Okay. The deflected warm current, depending upon the latitude where it is traveling, it may tend to lose the energy further. When it loses its energy completely, as and when it loses the energy, it gains density. It becomes denser and denser and denser, and the denser water slowly sinks down. So when it sinks, it pushes the water which is already present in the subsurface level. You just imagine all the surface water are red in color, all the deep water are blue in color. So this red column water will travel, and it sinks down and it mixes up with the red color, some blue color water, it become purple in nature. So this purple water will move down along the ocean floor, and as it moves further towards the north, okay, and it gains up the energy slowly from the surface current, and once it fully gains sufficient amount of energy, then it will become red in color again. Okay, so all the red should be at the top because red represents less density and more energy. Okay, so therefore again it after coming to the top, so the place where it emerges, no, that place is called upwelling region. The place where it sinks, these are the places where downwelling will be taking place. Downwelling means sinking, the surface water will sink. Okay, that place is called downwelling. The cold water where it emerges up is upwelling. The water which is emerges, the subsurface water which emerges, that brings up lots of nutrients, that carries lots of nutrients. Why it is loaded with nutrients? Because deep into the ocean there is no photosynthetic organism. The detritivores, all the dead materials will be deposited at the bottom only. So all the detritivores will break down the nutrients available over there, and mineralization will be taking place. Therefore, this region will be rich in nutrient, and the surface level nutrient level will be very very less because of the competition made by the phytoplanktons. So the phytoplanktons now they are able to get the nutrients uh, bring forward by the subsurface cold current, and as a result the upwelling places you will get more productivity in terms of fish catch. So now clear,
Yes, ma'am. Yes, ma'am.
Mahesh?
Yes, ma'am.
Nice. To some extent, so I could not hear you properly. Okay, if you want, you can put it in the chat box. So let me know your doubt exactly what you want exactly from me. What about others? Mritula, Pradeepa. So nowadays I'm not at all conducting any test. So very soon you will get a question, that is quiz and assignment. What about the assignment I posted yesterday?
We are doing it, working on it, ma'am.
Okay, okay. So do it sincerely. It would be helpful to understand better. I gave you the assignment on greenhouse gases, no? So do you have any doubt on that regarding understanding the topic which I gave you yesterday? See,
No, ma'am.
you,
No, ma'am.
yes, you please pay, you give sincere effort in doing the assignment, because nowadays everything is becoming online, right? So you may not be able to meet the teacher. Another thing is we want to give justification. So if you do it, that evaluation criteria I will post you. Uh, this evaluation criteria, the machine is doing the evaluation, right? So whatever the criteria we are setting, based on that criteria, evaluation will be carried out by the machine. So the mark will be accordingly, and therefore you please pay attention what is asked and you just try to answer those things. Another thing is try to avoid copying things. So I'm not telling you to not to refer any Wikipedia or Google. You please, you're 100% welcome to refer all those material to enrich your knowledge. But after reading those material, you just put it in your own word. Because if I check with plagiarism tool, easily you will find out. Okay, I can find out who has copied, who has given their original effort. Okay, so please avoid copying things where you need not worry about the grammar and all initially, but grammar also plays tremendous role. So once you start doing it, then your English also will be getting better and better. Okay, so don't think it, don't consider it as a punishment. You take it as an opportunity, so that you will tend to read more resources and your knowledge will become wider and wider, and your ability to put it in writing also will get improved. ultimately you are going to get benefit out of it. So in that temperament, if you start doing the assignment, definitely your the outcome will be very good. Okay, that's what I want to say here. And so please avoid submitting handwritten material. So I might have put it as a handwritten, please, that is a mistake. It should be purely typed one, and don't send it through email. So in your classroom you can post it, or you can send the link also. No link at all, you just post it in the classroom. Okay, so after evaluation is done, I will return it so that you will get the scorecard. Okay,
Okay, ma'am.
so shall we wind up the class?
மேம் நீங்க கொஸ்டின் அனுப்புனதுல கொஞ்சம் blank பேஜஸ் இருக்கு. ஸோ அதுலயே தான் பண்ணணும்னு வந்திருக்கா, இல்ல எதனால அந்த blank பேஜஸ் அப்படின்னு தெரியல.
இது ஜாம்போர்டு தானே நான் அனுப்புனேன்.
பிடிஎஃப்
I
ஒன்று வந்திருந்ததே
posted two
மேம்.
assignment, one for NCC and one for you people. And
Oh.
so did you? I posted the material under what to say, classwork, right? Under the tab classwork.
எஸ் மேம்.
Okay. Otherwise, some of you can you send me the screen capture of that assignment?
எஸ் மேம்.
Okay, so let me see how it looks. Actually, I did the assignment on Jamboard. Okay, so then after that I gave the link, Jamboard link with Google Classroom.
ஓகே மேம்.
Okay, so maybe because of that it may look blank, but no need to do it in the material which I posted. You create a separate document.
ஓகே
And,
மேம்.
you write your assignment on that and save it as whatever the title I gave, assignment 1, then topic, right? Similarly, you post it assignment 1 and topic, module 1 or module 2, I don't remember, module 2, right? So module 2, then assignment title, greenhouse gases and residential period, and the global warming potential of these gases, and sources from which you got those information is also important. These are the evaluation criteria. So I'll be looking for the references. I'll be looking for the originality, and then how seriously you have put the effort, and there should not be any grammar mistake. So you just check it with the spelling, and what else, the presentation, how you have presented your content, how the introduction, how what all that subtitle you have given, whether you have answered to the question which I posted under assignment. So whether you have covered the entire topic perfectly or not. So these are the criteria based on which your assignment will be valued, and you will be given 10 marks for that.
Yes, ma'am.
Okay. So if there are no doubts, so we'll wind up the class. Okay. Thanks for joining. Thank you all. Take care.
Thank you, ma'am.
Thank you, ma'am.
See you in the next.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.